All right, welcome back to math. Today, we're going to talk more about probability, specifically experimental probability. So, the difference with experimental probability and regular probability is that experimental probability is based upon information that you have gathered yourself to try and get something about. So we could say something like, okay, I have this spinner, and it looks like this, and we'll cut it in to 4 sections. I've got that's not what I meant to do. I've got a green section. Pretend that there's not a red background on there. I've got a blue section, and I've got 2 red sections. And so then on here, I've got my spinner. There's my spinner. Now, I sat here, and I spun this spinner 1,000 times to see how likely would it be for me to get something to happen. And out of that 1,000 times, the blue happened 267 times. The green happened 285 times. And the red landed on it about 448 times. Now, if we were to look at this, we would say, well, blue should be 1 out of the 4 sections. It should be a 25% chance. With experimental probability, I learned that it's actually a 267 out of 1,000 chance of happening, which when I divide that, it gets me a 26.7% rate, which is very similar to what it should be. Right? It should be 25. It ended up being 26.7. That's experimental probability. It's basing probability off of things that have already happened. Okay, that works with doing stuff like, let's say I wanted to look up sports stats. Okay, and I wanted to look up who was the best, or who should I choose to shoot free throws in a basketball game. Right, I'm playing a basketball game, and I want to look at who should I choose to shoot free throws. And so I'm going to go talk to Mr. Lambert, and I'm going to say, all right, Mr. Lambert, I need to know, out of your top 5 players, who should we choose to shoot free throws in the staff for students basketball game? And we'll say, okay, well, let's look at Tyson. Let's look at Quinn. Let's look at London. Let's look at who else could we look at? We could look at Henry, and we'll look at Bennett. So, okay, out of these 5 boys, and we tracked all their stats for the year, we're going to say how many were made out of how many attempts. And then here's going to be the probability. It's probability. All right, so if I were to do this, I would say, okay, well, looking at the stats, it looks like Tyson, he made 51 free throws and tried it 80 times. Quinn made 46 free throws and shot it 64 times. London made 40 free throws, shot it 59 times. Henry made 52 free throws, shot it 79 times. And Bennett made 16 free throws, and shot it 25 times. And so then here we want to look at, okay, what's the probability that they'll make a free throw? Well, let's do the math. We've got 51 out of 80 equals about 64%. So Tyson makes about 64% of his free throws. Quinn has 46 out of 64. Quinn makes about 72% of his free throws. London makes 40 out of 59, which is about 68% of his free throws. Henry makes 52 out of 79, which is about 66%. Bennett makes 16 out of 25, which is about 64%. So we can see that whoever has the highest percent would be the best free throw maker, which in this case would be a 72%, which in this case would be Quinn. So Quinn, this is going to be for you to go into the staff versus students basketball game and make those shots and make the students look better than they are, because you're going to be the guy who can do that. Unlike Tyson, London, Henry, and Bennett, who clearly can't shoot baskets as well as you can. All right, so that's experimental probability. One more thing when we talk about experimental probability is talking about what we call a simulation. A simulation. And a simulation is a model of a real life situation that allows for experimental probability. Okay, so a model of a real-life situation that allows for experimental probability. So let's say that I knew that my let's go back to Quinn. Let's say I know that Quinn, looking at our basketball scores, okay, here's our basketball scores. Quinn makes 72%. Henry makes 66% of his shots. 66% is like 2 out of 3. Okay, so Henry makes about 2/3 of his shots. So if I were to take that and say Henry makes 2/3 of his shots, I'm going to see out of the next 10 shots, can Henry make what he's supposed to make? So the way I'm going to do that is I'm going to actually roll the dice. And I'm going to say, okay, if I have 6 numbers on a dice, I'm going to say that if I roll a 1, 2, 3, or 4, Henry's going to make his shot. If I roll a 5 or 6, Henry's going to miss, right? Because 4 out of 6 is the same as 2 out of 3, which will give me what I need here. Okay, so 1, 2, 3, 4, 5, and 6. Now, if I made a table to track all of this data, I would say shot 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now to take this dice over here. And I would say, all right, let's roll this dice. 1, 2, 3, 4, he makes it. 5 and 6, he doesn't. 1, he makes a shot. 2, second dice, he makes a shot. Third shot, he makes it. Fourth shot, he makes it. Fifth shot, he makes it. Way to go, Henry. Shooting well right now. 6th shot, he makes it. This must be a weighted dice. 7th shot, he makes it. 8th shot, he makes it. There is a 5 and a 6 that should show up. 9th shot, he makes it. And 10th shot, he does not. So my simulation says that out of the next 10 shots, Henry's going to end up making 9 out of 10 of his next 10 shots. Way to go, Henry. That's a good amount of shots to be making. I believe in you. You can do it. So that is experimental probability. We'll talk more about that tomorrow. But for now, have a great rest of your night.